Uh, all right. Hello and welcome everyone. Today we have the pleasure of having with me Pratyush Goel. Pratyush, how are you?
Hey, I'm good, Ahmed. How are you?
Fantastic. So, folks, we've been talking about a number of topics, and one of the things that I'm particularly excited about discussing here is performance and reliability. And I think it's not often at our scale that we find, 8x or 10x type improvements. And I think we found something this time that I think is quite interesting. And we just wanted to, in the name of transparency, try to sort of share that opportunity. And I think it's an interesting case study on what it takes to find opportunities like this. Typically, at our scale, they're usually not just clear software problems or opportunities. It's usually about some combination of software and hardware and maybe the infrastructure that you're sitting on top of that work in such a way that you're able to discover that there's anomalies that if you go to fix could help you at your tail latencies. And we found such a use case. So Pratyush, maybe you can give us a quick glimpse of what it is exactly that was happening, and then maybe I can ask some follow-up questions.
Sure. Let me pull up computer and share my screen once.
Okay, sounds good.
Yeah,
Okay, so
let's
maybe
ask.
speed it up. So I guess you've probably written something down about this as we were sort of solving it. So I guess you're gonna pull that up.
Yeah, sure.
Okay. And I think like when I say 8x, 10x, so from what I remember, it sounds like this isn't like we were looking at our max latencies for workflows. Now workflows are sort of the heartbeat of agentic automation. So as you have agentic automations that are running in your system, you're gonna at some point call skills that call workflows, and at the end of the day, if there's an automation engine that's actually gonna make sure that certain tasks are being executed. And here in this particular case, it seems like in general, we had been looking at our P50s and our P95, meaning the median performance, the performance at the 90th, the 95th, even the 99th percentile actually looked okay. But if we explode into that document that you're looking at, it looks like there's one number that's actually going into close to 3 minutes. What is that?
Yeah, so this is like the max latency for each skill. So these are like the skills that we had in an organization, and these are the latencies for those skill executions. And as you mentioned, the average in P95 looks fine. However, the max latency, that is the latency that was required to execute the skill, was the longest, was really high in some of the cases. So
Awesome.
yeah,
Okay, so I mean that's not bad. Almost, I mean that's pretty bad, I should say. Almost 3 minutes. And for those of you who stick around for the next 20 minutes, we'll see how we drop that down, by 86%. But I think I think we did not have. First thing what we realized, the reason we were able to discover this problem, or the fact that we discovered it so late, is because we were not paying attention to max latencies. Is that correct?
yeah, that's like correct, but because these are like custom skills that have like their own business logic, and also it's not immediately clear as to whether it's due to like legitimate long execution or if it's a bug. Because these are custom skills, they can involve their own business logic, their own external network calls, which could be hanging network calls and so on. So like we
Exactly.
kind of lacked the ability to separate out our processing latency versus the actual business logic latency.
Exactly. And so to put it another way, just because the max latency for a particular skill is 3 minutes doesn't mean that that's a bad thing. It could just be that, legitimately speaking, this skill took 3 minutes because it's a
Yes.
longer running workflow. So, yes, the first thing that we realized was that our inability to actually tease out business logic latency from processing latency was a noticeable factor in why we were more or less ignoring what max latencies look like, and that hurt us because we felt like that was more of an anomaly related to business logic versus our own processing. So being able to tease that out was the first finding that we had. And I guess if you actually looked into this, you realized that this was not necessarily pure processing. These were artificial latencies that were being introduced due to exponential backups. Is that correct?
Yeah, that's correct. So, how it works is like we execute a skill, and if the skill fails, we kind of have an exponential backoff So like we first wait for like 30 seconds, we do a retry. If it fails, then we again along with an exponential backup, we like wait for 1 minute and then we again retry. So these are like artificial latency that gets added up on skill failures.
Mm. And so, okay, and I guess, for the audience, what we're trying to do is go through this in a methodical way, the five whys type of methodology, before we get into how we actually resolve the issue. So clearly we understood that because max latencies were not being separated from business logic latencies, they weren't being maybe reviewed as closely as the P95s and the P99s. So we first resolved that. Then we realized that the max latencies were being impacted by exponential backoff. And then I think the question is, why is there even an exponential backoff? It seems like there were multiple retries that were actually impacting specific workflow runs. So tell me about that.
Yeah, so like in this case, we went deep into why the actual skill was failing during that time. So we kind of like related that with the reason of failures, and we realized that okay, there's this like there's this pod auto scaling that is happening. So like whenever we had an auto scaling event, that would essentially cause these in-flight skills to fail, and then those would go into retry and have these uh, you know delays added up.
Got it. Okay, so first thing we did was figure out a way to actually accurately, authentically look at our max latencies. Then we realized that there were exponential backoffs that were happening that were artificially inflating the latencies. We realized that the artificial backoffs were happening because we were triggering multiple retries, and that allows for the latencies to balloon. The multiple retries were because of invocation failures. The invocation failures were because of pod shutdowns. Pod shutdowns were because of auto scaling activities.
Yeah.
Got it. Interesting. So now the question is, why is that impacting the workflow at all? Because you could have auto scaling activities, but because of the graceful nature of how workflow execution runs are actually being performed, it shouldn't necessarily impact, or should it?
Yeah, it shouldn't be impacted. Like auto scaling should never impact your in-flight executions that are happening. So that's what we found. What was happening earlier was, like, you can say we have like a pod that is kind of executing 10, 100 or thousands of skills parallelly. Now whenever a signal would come that okay, you need to shut down this pod, and the reason for that signal could be like like downscaling event and so on. So then that what would happen is we would first stop, like that pod would stop accepting any more requests for, and it would stop scheduling any more skills on that instance, and then it would kind of cancel the ongoing activities that were happening. So if it would cancel all the ongoing activities, those skill executions or the activities would fail, and then that would essentially cause those skill failures and lead them into retries delay.
Yeah, makes sense. And I think what's really fascinating is for those who are listening, when you're doing performance analysis, even if you're running at scale to see what your performance looks like, unless you're uh, actually triggering this sort of downscaling and auto scaling in your performance environment, which we did not, we it's very difficult to actually identify these types of scenarios. So again, if you're doing performance analysis to see how many workflows you can run, or what the performance of workflows looks like at scale, you may feel like the system's working because a appreciably large pod can take on a number of parallel workflows and actually perform admirably, which is why our median performance and even you know 90th to 95th and 99th look really, really good. And in a sort of contrived performance benchmarking scenario, even the max latency would look fine. It's only when you actually go from very high workloads to very small workflows and you actually initiate a downscaling event is when we would have identified the problem in our graceful shutdown handling, which we did not discover. And that's not just about the way the graceful was implemented, but it's also a little bit about how we were doing performance testing, which had to change as well.
Yeah.
Okay, so now let's get into what the nature of these skills are. Maybe you can tell me a little bit about them, because we've got a lot of different types of nodes. So for folks using our engine, they're going to be able to trigger through webhooks and APIs and through observed events and change events, a number of workflows, and these can be described in no code or low code ways. And there's a number of different types of nodes. Some that are able to invoke artificial intelligence to summarize and cluster and prioritize or sequence things. Some are processing conditionally logic of different fields and attributes within the system of record. And then there are others, like for example, the HTTP node that allow you to arbitrarily connect to the long tail of IT services you might already have in your system or are available externally to actually execute some tasks in a separate set of infrastructure. So tell me in this particular case, what is it about this HTTP node? Because it looks like this workflow was related to it, how
Yeah.
HTTP are set up and what is special about them.
Yeah, in this case, the HTTP node itself was calling an external API that was internally calling an agent system. So essentially, HTTP node was kind of a bridge between two agents, where the first agent would use the second agent as a skill and call it with the help of HTTP node. So it was like a multi-agent system where our orchestrator agent would call a child agent via a HTTP API request,
I
and that
see.
yeah,
Good.
and that agent itself was taking a long time to process because that agent was internally then calling multiple skills, doing the reasoning and all that, which caused the skill latency for that specific to like go to like 20-30 seconds, making it a long running skill.
That makes sense. And now tell me this, like I know one of the things that we always pride ourselves on is the fact that by running our workflow runs as stateless operations, we can actually asynchronously handle at scale just a very, very high number of workflows. But here we've also talked a little bit about this pod, this containerized deployment. So maybe you can tell us a little bit about how these things connect. Maybe you can get into a little bit of the architecture in terms of why we have this combination of lambdas as well as this containerized pod.
Yeah, sure. So like what we have is like uh, we have like two types of operations at DevRef. One would allow you to write custom logic, which was this case, and logic is like really like it can the latency or the execution time for that is variable, and when that is the case, we would want to run them into a Lambda environment so that it just scales better. Apart from that, we have some native nodes as well, which are implemented in our own system, so they are run into our own container deployment because there we know what the uh, what the execution times look like, what the operation is supposed to do. So we have like kind of like both type of dual architecture where some are native nodes that are executed in our system, while we also allow the ability to write your own custom logic, and that is run inside the Lambda itself.
I understand. So, I mean, just to do a quick recap so far. So, the nature of the problem, what are the ways to identify these opportunities? Because remember, like these are some of the ways that like complex systems start to, demonstrate performance variation. First thing we've said is, as opposed to looking at P90, 95, and 99, which is really about, what is the customer impacting performance, at the 1%, 5%, 10%, and so on, to really looking at max and being able to set up your latency tracking in a way that helps you understand how to separate concerns between business logic and normal processing logic at scale. So that's the first thing we identified. The second thing was to really kind of think about, our actual infrastructure. Here in this case, we have a containerized deployment that auto scales and understanding how auto scaling could impact performance, and particularly performance when there's retries involved because of handling that's not being done gracefully. So we looked at that. And then, of course, number three is to sort of understand what's happening at that intersection between the combination of what you called our native node performance and the high code sort of a custom node performance, which is being handled by Lambda. So here we're sitting at another curious intersection, which is this intersection between running things synchronously and asynchronously. And what you're seeing here is perhaps there is some unnecessary synchronous processing happening, perhaps, right?
Yeah, that's true. So like our lambda over here was being called synchronously, which essentially made it like susceptible to failures, that okay, when the pod was shutting down, and since we were not handling it gracefully, it would cancel the synchronous operation and cause it to go into retry.
Yeah. And so now in terms of just solving the issue, like obviously with the things that we called out, you're able to improve performance. What did the after performance look like? I mean, we talked about getting close to 3 minutes with that one skill. Now, mind you, I mean, in a system of handling millions and millions of workflows, this was happening at a very small clip, but it was happening. So what is the workflow after result look like? Maybe you can explode that and show it to your scale.
Yeah, so one thing I would add is like I would just go through is kind of like this diagram that kind of shows this one. The below chart is like number of executed, like number of workflows we're executing daily.
Yeah,
So you can see on like 12th of November we had like around what 800,000 executions,
yeah,
and
okay.
on 12th of November, whereas the number of workflow runs that were retried is around 1,000. So which is why like it's a bit like it kind of
Yeah.
like slipped, I would say,
And just to be
because
clear, like a retry does not necessarily mean that the workflow actually failed. In fact, none of these actually failed. These are actually getting retried and succeeding. It's just that the max latencies were being impacted, and that was not revealing itself at any other percentile that we tracked. Tell me this, and of course, the fact that the retry events actually went down to zero effectively is where your change went in, correct?
yeah, that's correct. So after like 28th, that's when the change went in. We don't
Yeah.
see any more retries, and yeah,
And let's look at the latencies. Like after your change goes out, what do the latencies look like? So we had the max of 3 minutes, and that max turned into what, 23 or 24 seconds?
yeah, correct. So it's like max is now closer to P95, and because there's no retry latency that is being added up, so it's actually a business logic latency which is high
Yeah.
in these cases now.
And I think this is one of my favorite ways of finding performance optimizations at scale in a production setting. Because once you've sort of figured out what your algorithms and design decisions are, once you understand how your data flow looks like in terms of caching and what type of record formats you want to use and how you're serializing, deserializing information. All of that sort of becomes pretty obvious when you do a performance test. But as you get into production, like again, you're going to have a lot more infrastructure and sort of scale complexities that arise. So there's always that opportunity to discover more process optimizations. And one of my favorites is looking at sort of the ratio between P50, P90, or P90 and 99, or maybe even 99 and max. And here what we're seeing is that there was a multiple between P99 and max that if we were able to actually track that number accurately without necessarily having it be polluted with business logic, you would actually find a huge opportunity to improve performance, which maybe improves 0.001% of workflow runs, but still at scale when organizations are running hundreds of thousands of workflows daily, you're still going to get some level of impact. Maybe it's one or two workflows that are a little longer, but you'll see it. Or somebody in an organization of hundreds of people would probably see it once a day or something like that. At some point, it starts to matter for sure. And I think we're at that scale where even something that's impacting one person out of a 500-person organization once a day matters, right? So what else can you show us? I mean, now we've understood the details of how we discovered the problem and how we teased out the observability to actually validate the problem and go through the details of it. What other like sort of opportunities do we have to optimize this further as we look forward, or maybe things that we've learned that we need to have better observability around?
Yeah, so one thing, one thing that we definitely like solved uh, was this itself adding the graceful shutdown. However, another thing would be removing the synchronous dependency between the lambda execution uh, itself. Like we can just call it asynchronously, so that these things like we don't have a really long network calls that are waiting. And apart from that, on the observability front, we would need some like we are adding some metrics around to separate what is the like to separate the business logic latency from the your actual time it took to execute the skill. So that would include the platform overhead. That would be like how much time does it take to schedule the skill, and how much time is it to receive the skill, schedule the scheduling in the Lambda, receiving the response asynchronously. So all those metrics, those are something that will be adding to ensure that okay, and to ensure that okay, the platform overhead is like close to like minimal or zero, would be the aim, and the actual latency would be as close to the business logic latency itself.
That's right. And of course, we should, I don't know if this was in your action item list, but we should definitely change the way we do performance evaluations to have some level of variation in the workload, which would then trigger, to confirm that we're triggering auto scaling events in both directions, downscale
Yeah.
and yeah. Okay, outstanding. Sandeep Singhal says very informative. Great. So thank you for watching. Now, where do we want to go from here? Because obviously, now that we have this learning, one of the best things about having a learning like this is that you start to get greedy and you say, okay, you know what? We have a workflow engine, but we also have an authorization engine. We also have an identity management engine. We also have, a gateway. So there's a number of components within our architecture. And of course, like many complex platforms, we have over 300 microservices. Not to say all of them have this level of complexity in terms of how they work, but even our AirSync connectors, there's a lot of technology in our AirSync platform. So how do we take these learnings and start to apply it to, for example, AirSync connectors or our authorization layer, so that we can actually figure out, okay, you know what? Let's see what the multiple is between P99 and max there. And we're going to have to go through the same exact exercise, right? We're going to have to figure out how to, disambiguate the max latency from just what I would call business latency, business logic latency, from actual processing latency. Because that's the number one reason, just like we had done, that people ignore certain observability measures, is because they think it has to do with what the customer is doing with the technology, because they don't know how to tease it out from where the technology itself is introducing artificial latency. So how do we take this action and sort of go into maybe one of these other technology platforms that we have?
Yeah, so like no system, like there's always a scope of improvement in performance in every system. And yeah, as you mentioned, like we have multiple complex systems at DevRev. So I would say we would like to first get the metrics around separating the actual business logic with the platform overhead that we have. And once we get observability on top of that, that's when we start digging into okay, let's go into the exercise of optimizing and find out okay, what are the potential bottlenecks, and then keep on fixing them. But
Yeah.
yeah, first we need to add the observability on. Like we already have the observability, but I'm sure we might not have at some places. So ensure the observability is at every place, and then go on to uh, improvising it.
And I think like it's also interesting to understand that just because you're using some sort of cooked meat in this particular case, like you're using a containerized deployment, and there is the ability to auto scale. Not everything, auto scaling is never perfect. Now, it's not just about graceful handling and shutdowns and so on and so forth, but even auto scaling itself is not perfect. I mean, I think it would be really interesting for anybody that's built in a cloud native way to actually look at how many cloud auto scaling events are actually happening for a particular service that they have that's using auto scaling, and to actually see how effective their auto scaling is, because again, auto scaling doesn't happen instantaneously. So if you actually need to do auto scaling constantly, you may want to review what your default configuration looks like, and really understand, hey, is this something that should even be using a containerized deployment, or maybe I need to be using a slightly different type of architecture to actually execute whatever needs to be executed. So I think there's a lot of ways to take this information to start getting even more hypercritical, because that's where you start to investigate and find problems, areas, opportunities for performance to get better. It's not just about whether you have a pod and whether it's able to successfully run whatever it is that needs to be run from a request processing, request handling perspective. You may want to look at how many of these events are actually happening, because that could indicate a number of things. Yeah. What else? What else have we learned from this? Like, I mean, if you were to take this and say, okay, you know what? Forget our own components, but what about our dependencies? Like, one of the largest dependencies is LLMs for a system like ours, using large language models for planning and reasoning, using them for coming up with natural language responses and many other ways. Like, how do you think about that? Like, how do we take these learnings and actually start to get even better with our observability around LLMs and usage of LLMs and time to first token and parallelization and everything else?
Yeah, so yeah, that's true. Like even LLM calls are like kind of long running network calls that are happening in our system at different places, and even that like there's potential problems that could happen where the network call hangs up or the time to first byte token takes a bit of time. It like never comes or it comes after 15 seconds. So in those cases, we need to add better handling at different places. So for example, okay, one thing could be that okay, if your time to first byte like time to first like if your first token is not received within the first 5 seconds or something based on your benchmarks of the model, you would cancel the request and again retry, so that you eliminate those spikes of that are happening in between. Another thing could be like having retries on top of it, that okay, if your LLM call has not returned your response within 10 or 15 seconds based on what your actual expectation of the call is, you would want to add retries on there. So there's multiple different ways of like we would want to improve when we're calling LLMs.
Yeah, and I think in our particular case, I would say that maybe there was a maybe a hypervigilance around more of the LLM interactions, which is why probably some of these other interactions between systems, were left with maybe a little bit more neglect. But in general, I think what this indicates is that even in a system that people might look at and say, oh, this is just sort of a layer on top of LLMs or what have you. It's really not. It's very complex, right? I mean, to do this right, it's a combination of the frontier models, or models in general. But then you've got the data layer, you've got the execution layer, you've got the optimization layer, and then you've got sort of the application layer where perhaps people get to define their own logic or what their end goals are. And of course, all of those things have to work in unison. And it's often at those intersections that you find the most performance opportunities at scale once you've sort of figured out how to create the end-to-end functional experience. This is great. Where next then, Pratyush? Like, I mean, obviously we've gone through this exercise. We've talked about how we could maybe leverage this to get better observability metrics in some of our key platform components, and then sort of dig at those intersections. Are there any other learnings that you want to show us from this exercise?
Uh, so one would be observability, having the correct configuration, having the right architecture, and ensuring how do we replicate this across different parts of the component so that we can use these learning and apply it everywhere.
Yeah, I think one of the other things that I'll mention that I thought you and I got a good chuckle out of when we were discussing this earlier was the fact that especially when it comes to things being handled synchronously or asynchronously, sometimes like drawing out the diagram is often the best way to actually build the intuition because it's usually scenarios where you think it's obvious what needs to happen and you start to implement it, that you forget that you may be introducing unnecessary blocks or weights, and they may not necessarily manifest in terms of network latency or even CPUs because it doesn't take a lot of CPU cycles to actually wait. But it could be taking a lot of blocking threads, and you might run out of threads and then have to do an auto scaling event. So it's possible that under the wrong architecture, where you might be blocking unnecessarily in a synchronous way, waiting for some action to be completed, your CPU looks just fine, your memory looks just fine, your network looks just fine. However, you're triggering auto scaling events. Not to say that's what happened here, but these are the types of scenarios where when people overly fixate on network, memory, and CPU, it's also very important, especially in a system like we see today, which is cloud native, auto scaling. Nobody has to know what's happening. You just pay the bill at the end of the month. You might forget that, hey, listen, I've got some unnecessary blocking happening in my architecture, and it's causing auto scaling, and auto scaling isn't free, and auto scaling is not perfect. And so I need to avoid that if possible. So I would always urge people, like, if you are using auto scaling, understand when it's being triggered, why it's being triggered, and don't just fixate on CPU and or memory or latency on the network side. Take a look at the entire thing, understand if there's some unnecessary blocks. This is where a lot of times in environments like QA and pre-production, people also like to take a snapshot of what's happening in memory, see how many threads are active, how many are waiting, how many are blocked, how many are executing in live, just to kind of understand what performance looks like, in the details versus just trying to look at a quick old snapshot saying, okay, it looks like we're not using the entire 10 gig network interface, or the network latencies look fine, CPU is under 20%, memory is less than 10% utilized, we're fine. Which is usually where performance evaluations stop, but there's a lot more that can be done. Thanks again, Pratyush. Any other last final words? But folks, for those who have joined us, I hope you found this informative. We're going to put this on YouTube as we typically do. And of course, you can join us on Discord, where as a community we like to discuss topics like this and many others. Any final words, Pratyush?
Yeah, just draw the architecture diagram. Sometimes it brings up stuff you miss out otherwise.
Absolutely, it makes it so obvious, and it's really easy to do it on a screen or in a document and just wipe it clean and start again. And it's a great way to learn. But I mean, I'm excited that we found this. It's a one in a million type of thing, but you find it in one place and you can fix it in 50 different services, right? And it really kind of gets people excited about observability and performance again, which I'm always keen to get people excited about. So hopefully, folks learned something here. I appreciate, Pratyush, your participation today. Folks, we'll see you guys next week again. Thank you.